Hello friends, in previous session we have studied direct proportion. Now in this session we will discuss about inverse proportion. Two quantities may change in such a manner that if one quantity increases, the other quantity decreases and vice versa. For example, as the number of workers increases, time taken to finish the job decreases. Similarly, if we will increase the speed, the time taken to cover a distance decreases. To understand this, let us look for the following situations. Nidhi can go to her schools in 4 different ways as shown in the table. She can walk, run, cycle or go by a car. Study the following tables. Here you can see the speed in kilometer per hour and the time in minutes. The speed are by walking 3, by running 6, by cycling 9 and by car 45. And the times in minutes are 30, 15, 10 and 2. Observe that as the speed increases, time taken to cover the same distance decreases. As Nidhi doubles her speed by running, the time reduces to half. As she increases her speed to 3 times by cycling, time decreases to 1/3. Similarly, as she increases her speed to 15 minutes, time decreases to 1/15. Or in other words, the ratio by which the time decreases is inverse of the ratio by which the corresponding speed increases. Can we say that speed and time change inversely in proportion? Let us consider some example. A school wants to spend rupees 6,000 on mathematics books. How many books could he bought at rupees 40 each? Clearly, 150 books can be bought. If the price of a textbook is more than rupees 40, then the number of books which could be purchased with the same amount of money would also be less than 150. Observe the following table. Here you can see the prices of books and the number of books that can be bought. What do you observe? You will appreciate that as the price of the books increases, the number of books that can be bought keeping the fund constant will decrease. Ratio by which the price of the book increases when going from the 40 to 50 is 4:5, and the ratio by which the corresponding number of books decreases from 150 to 120 is 5:4. This means that the two ratios are inverse of each other. Notice that the product of corresponding value of two quantity is constant, that is 40 into 150 is equals to 50 into 120, that will be 6,000. If we represent the price of one book as X and the number of books brought as Y, then as X increases, Y decreases and vice versa. It is important to note that the product XY remains constant. We say that X varies inversely with Y and Y varies inversely with X. Thus, two quantities X and Y are said to be in very inverse proportion if there exists a relation of the type X into Y is equals to K between them, K being a constant. If Y1 and Y2 are the values of Y corresponding to the values of X1 and X2 of X respectively, then X1 Y1 is equals to X2 Y2. That will be is equals to K, that is constant, or X1 upon X2 is equals to Y2 upon Y1. We can say that X and Y are in inverse proportion. Hence, in this example, a cost of a book and the number of book purchased in a fixed amount are inversely proportional. Similarly, speed of vehicle and the time taken to cover a fixed distance changes in inverse proportion. Here, you will observe a table. X and Y values are given. The values of X are 100, 200, 300 and 400. And the respected value of Y are 60, 30, 20 and 15. The ratio by which X increases when going from 100 to 200 is of ratio 1:2, and the ratio by which the corresponding number of Y decreases from 60 to 30 is in the ratio 2:1. This means that the two ratios are inverse to each other. Similarly, the ratio by which X increases when going from the 200 to 300 is 2:3, and the ratio by which the corresponding number y decreases from 30 to 20 is 3:2. Again, we find that ratios are inverse to each other. Now, if we will see the values of x from 300 to 400, the ratio will be 3:4, which is inverse of the ratio 4:3 of the number y. Therefore, we can say that x and y are in inverse ratio to each other. Here we should note that when two quantities x and y are in direct proportion or they vary directly, they can be written as x proportional to y. Here you can see it. When two quantities x and y are in inverse proportion or vary inversely, they can also be written as x varies inversely. Here you can see it. Now we will see some more example of inverse proportion. Example 1. There are 100 students in a hostel. Food provisions for them is for 20 days. How long will these provisions last if 25 more students join that group? Solution will be as follows. Suppose the provision lasts for y days when the number of students is 125. We have the following table. Here you can see number of students are 100 and 125. The respected values of number of days are 20 and y. Note that more the number of students, sooner would be the provision exhaust. Therefore, this is the case of inverse proportion. So, 100 into 20 is equals to 125 into y, or y is equals to 100 into 20 upon 125, that is y is equals to 16. Thus, the provision will last for 16 days if 25 more students join the hostel. Alternatively, we can write as x1 into y1 is equals to x2 into y2, as x1 upon x2 is equals to y2 upon y1. That is x1 ratio x2 is equals to y2 ratio y1. Now we will get 100 ratio 125 is equals to y ratio 20. The y will come as 100 into 20 upon 125. The final value of y will be 16. Now we will take another example. If 52 men can do a piece of work in 35 days, in how many days 28 men can do it? The solution will be, suppose 28 men will do the piece of the work in x days. The given information can be exhibited in the following tabular form. Here you can see the number of men are 52 and 28, and the number of days are 35 and x. Here the value of x we have to calculate it. Clearly, less the number of men, more will be the number of days to finish the work. It is therefore the case of inverse variation. Therefore, the ratio of men is equals to inverse ratio of number of days. That is, 52 ratio 28 will be is equals to x ratio 35. From here, we have to calculate the value of x. 52 upon 28 is equals to x upon 35. So, the value of x will be 52 into 35 upon 28. That will be is equals to 65. Hence, 28 men will do the work in 65 days. Now we will consider one more example. Shalu cycles to her school at an average speed of 12 km per hour. It takes her 20 minutes to reach the school. If she wants to reach the school 15 minutes, what should be the average speed? The solution will be, let the required speed be x km per hour. Then the given information can be presented in the following tabular form. The speed in kilometer are 12 and x. Here the value of x we have to calculate, and the time in minutes are 20 and 15. We note that more the speed, less will be the time to cover the given distance. So it is the case of the inverse variation. Ratio of speed is equals to inverse ratio of time taken, that is 12 ratio x is equals to 15 ratio 20, that is 12 upon x is equals to 15 upon 20. 15 into x is equals to 12 into 10. 15 into x is equals to 12 into 20. That is, the value of x will be 12 into 20 upon 15. That is 16. Hence, Shalu's average speed should be 16 km per hour. Now we will see one more example, that is example 4. If x and y are in inverse ratio to each other, and x is equals to 10 and y is equals to 6, find the y when x is equals to 15. the solution will be, since x and y are inverse to each other, therefore the product xy always remain constant. That is 10 into 6 is equals to 15 into y. From here we will calculate the value of y. That is 15 into y is equals to 16. That is y is equals to 60 upon 15. That will give the final value of y is equals to 4. So this is all for this chapter, direct and inverse proportion. I hope you enjoy the learning. For further information or you have any query, please go through the following link.